All right, I'm back. I wore Archer out. I'm too fast for him. He tries to play keep away. I catch him just about every time. That's a lie. Now, let's see. Formula for mean and standard deviation. We're looking for a shortcut. For a binomial setting with n trials, and the probability of success p, and the probability of failure q. Here's a formula. Ready for this? The mean is mu of x equals n times p. How awesome is that? Look, instead of, when you have these, instead of doing all of these, you can just go n times p. Are you ready for this? The mean of x equals, I'll put this in a little bubble right there. 5 times, what was my probability of success? It was like 0.36 or something, wasn't it? Let me go back. Sorry. A little less prepared than I thought I was. I guarantee I'm doing this on the next page anyways. The probability of success is 0.36. 5 times 0.36. Ready? 5 times 0.36. 1.8. Boom. Instead of writing all that stuff out, I could have just multiplied the two of them. So there's shortcut number 1 is for the mean. Shortcut number 2 for the standard deviation, just as cool. The square root of n times p times q. And q is the probability of failure. So for example, find and interpret the mean of picking our 5 students. Mu of x is equal to n times p. And so that's 5 times 0.36, like we did on the last page, is 1.8. The standard deviation is the square root of n times p times q. So that's going to be the square root of 5 times 0.36 times 0.64. What a huge, monstrous, awesome shortcut. That's equal to 1.07. You know, there's not enough room here to write the whole interpretation, so let's shortcut that up a little bit for our notes. On average, we would have 1.8 successes over many trials. Okay, so I really shortcutted that. What I should be writing is, if I went through the process over and over of picking 5 students from Larson's class, I would expect, after I keep track of all of them, to have an average of 1.8. But I think I shortcutted that up pretty good. And then this one will say, and those successes, if I did this a whole bunch of time, would differ from mu of x equaling 1.8 by an average of 1.07. Okay, there's a book example on page 358, it looks like. Let me get myself a Libro. I just narrowly missed dumping a whole bunch of stuff off my desk. I'm sure you guys would have enjoyed that. Okay, on page 358, I think this is going to go pretty quick. Here we go. How many correct on the pop quiz? Oh, so this is our pop quiz thing. To introduce her class to binomial distributions, Mrs. Desai does a pop quiz activity that we did. 10 multiple choice questions, A through E, so their probability of success was 0.20, not 0.25. Calculate and interpret the mean and the standard deviation. So look how easy this is, guys. The mean is 10 times the probability of success. It's just 2. If the students did this over and over, we would expect the average amount that they get right to be 2 out of 10. The standard deviation, square root of 10 times 0.2 times 0.8, 1.265. If the students did this over and over, we would expect the amount they got right to differ from the average of 2 by an average of 1.265. Pretty simple right there. Now let's talk about cumulative probabilities. My example, back to picking the 5 students. What's the probability that when I pick 5 students, the number that got an A is less than 3? Okay, so that's the probability that x is less than 3. Well, that means the probability that x is equal to 0, or 1, or 2. And so, going back to the probabilities from the other page, I'm going to go grab those right quick, 0, 1, and 2, and add them together, right? So those would be 0.1074 plus 0.302 plus 0.3397, and when I add them together, I get 0.7491. Okay, now, wouldn't it be nice if there was a shortcut formula? Instead of having to go find three probabilities and add them together, wouldn't it be nice if there was a shortcut? There is one, and it's on your calculator. I'm going to show you a new trick on your calculator today. All right, the function binom CDF NPK. Binom CDF NPK. Go ahead and write that down. Stands for binomial cumulative distribution function. It adds up the probabilities for x equals 0, 1, all the way up to whatever k you want to pick. So the calculator actually finds all those probabilities and then adds them up. I mean, how badass is that? So hang on just a second and I'll show you what I mean. All right, so we have this scenario. This was from a binomial setting where I'm picking 5 kids with a 0.36% chance. Now watch. I'm going to hit second and then the variables button for this distribution menu, second and distribution. And look at all these things that are on here. It's crazy. We're going to talk about a few of them this semester. If I go to binomial PDF, that gives me the probability for any one of these things. Ready? Watch. So number of trials, 5. I'm picking 5 kids. Probability of success, 0.36. And the x value, let's do this one for 4. Just randomly picking one there. When I hit paste, it gives me 0.0536. You guys see it? 0.0537. Sorry, I rounded differently apparently when I did this. I could do it again and get 2 or 0 or any of them. So what I'm telling you is that on this last page, the binomial CDF stands for cumulative distribution function. So when you put in an x, it'll find the probability that you get 0 successes, 1, 2, 3, all the way up to whatever number you put, and it will add them all together. Find this on your calculator by hitting second, the second button first. Hit the second button. And the variables button, which is right here, to get to the distribution menu. Then scroll down. Okay? For example, if the probability of snow on any given day in February is 0.25, that's a big assumption that it's the same percentage chance of snow every day. What's the probability that it's going to snow less than 6 times, less than or equal to 6 times? Well, that's the probability that x equals 0 or 1 or 2 all the way up to 6 times. I would have to find 7 different probabilities and add them all together. What we can do here is go, this is a binomial setting, 28 days in February, and 0.25 is a percent chance of success. Unless this is a leap year, I don't even know. If it is, just shut up about it. So anyway, this will go, the probability that x is less than or equal to 6 is just simply, this is how you show your work for this if you're going to use a calculator. Binom CDF for cumulative, meaning I'm going to add up all of these, of 28.25 and 6. You are telling the calculator to go find 7 different probabilities and add them up. So second and variables. Here's a trick, by the way. Instead of scrolling all the way down, if you scroll up, you get toward the bottom and you can find it quicker. So PDF gives you one individual probability. CDF adds from 0 up to the one you put in. So I'm going to hit enter. I'm going to say there are 28 days in February, so 28 trials. Probability of success 0.25, and I'm looking for 6 so that it will add up 0, 1, 2, 3, 4, 5, and 6. And there we go. That answer is 0.4279. Okay. Using the complement rule with binomial CDF, 1 minus, so this is why I would have to do this. If I'm picking the 5 students again, I'm going to find the probability that x is greater than or equal to 3. Okay? If I do that, greater than or equal to 3, I want this one, and this one. These are the ones that I want. But the binomial CDF adds from 0 up. You see what I mean? So I can't go from 3 to 5 with the binomial CDF. The binomial CDF starts at 0 and goes up. So here's what I'm going to do. Since all of these equal 1, I'm going to go 1 for all of these. then I'm going to go minus the binomial CDF of 5.36. And then what am I going to put here? I'm going to put a 2 here because I want to get 0, 1, and 2 and subtract it away from 1. That will leave me with this. So put that in the calculator. 1 minus, hit second and variables and go up to get to binomial CDF. It's quicker that way. 28.25, and then I'm going to put a 2 there, and it will add up 0, 1, and 2. And if I subtract it from 1, it'll give me this result right here. It's going to be 0.9834. I hope that makes sense for you guys. Did I do that right? Binomial CDF. 0, 1, and 2. I got 0.98. The number doesn't quite make sense. And I'm not sure why. Oh, I put 28, guys. That's just dumb. Look at that. That's the February thing, not these kids. Let's try that again. That's absolutely wrong. Sorry about that. 1 minus. Can't believe you didn't say anything. Are you guys here to help or what? So this should be a 5. And this should be a 0.36. And this should be a 2. There we go. Now that equals 0.2509. That makes more sense. Because I'm looking at the sum of these three things. I'm looking at it, I was like, there's no way that's 0.98. So 0.25, 19%, another 5%, that's about right. Okay, find the probability that it snows on more than 20 days in February. Okay, it's out of 28, right? We have n equals 28, and we have probability of success is 0.25. And if we want more than 20, the probability that x is greater than 20. So we want 21, 22, 23, 20, up to 28. So what do we want to get rid of? 0, 1, 2, 3, 4, 5, all the way up to, and we're going to get rid of 20 because our answer is going to be more than 20, right? This is equal to the probability that x is greater than or equal to 21. You see what I mean? And so if I want to keep 21 and up, when I do 1 minus, I'm getting rid of the ones I don't want. So 1 minus a binomial CDF of 28 days, 0.25 each day, and I'm getting rid of all the way up to 20, so that I will be keeping 21 and up. So 1 minus second variables, go up until you find binomial CDF, 28 days, 0.25 for snow, and 20. And that answer is, okay, we've run into this before, 4.01, but there's a e to the negative 8. That's scientific notation. That means you got to move the decimal place 8 units to the left, 8 spots to the left. So I go 1 to get past the 4, and then there will be 7 zeros. So my answer is 0.1, 2, 3, 4, 5, 6, 7, 401. It's not going to snow that many days in February, guys. Okay, there's a book example. I'm going to tell you, you guys could read that on your own. Your homework is on page 162 today. I'm going to stay off sapling because I'm low on time today, and I don't want to go look on sapling. So there's 3 problems from the book for you guys to do. All right, have a good day.